Yeah, you read the title right. Your head's on backwards. This isn't an insult. My head is on backwards too. Actually, all humans. In order to explain what I mean, we're going to have to go way back in evolutionary history. But first, a question that you might have had but forgotten. Why is it that the left half of our brains controls the right half of our bodies? And why does the right half of our brains control the left half of our bodies? Inside us, the connections from our brain to our body makes an X, something called decussation. And for a long time, this puzzled scientists. There wasn't really a good explanation, but there also wasn't a good explanation for a lot of asymmetry that we have. For example, why is our heart bigger on one side than the other? And not just our heart, a huge number of internal organs that we have aren't centered or symmetrical. In order to answer some of these questions, we're going to have to look at body plans. We have here a comparison between 3 different species, and this is a comparison based on what are called Hox genes. You can see at the bottom here, Hox A, B, C, D. And what they do is incredibly complicated, but you can think of them as control genes. Each Hox gene controls a segment of the body. So if you look here at the most simple of the 3 species that we are looking at, there's only a few Hox genes and a very simple body plan. But when we go to the second species here, you can see there are more Hox genes and very defined body segments. Then when you come here and look at a mouse, you see even more Hox genes and more complicated body segments, but notably still in roughly the same order as our second species here, which is a type of fly. But something might jump out to you looking at the comparison between species B and C here. Doesn't B look upside down? Or maybe C is upside down. Either way, it looks like B is looking up and C is looking down. In 1822, a French zoologist, whose name I will not attempt to pronounce, but it's written here, dissected a crayfish and compared it to a vertebrate. And he noticed the same thing, which is to say that arthropods, type of invertebrate, appeared to be upside down from chordates, the group of organisms that includes all vertebrates. So what he assumed is that some early chordate ancestor had somehow got upside down, and that had stuck as an adaptation. Unfortunately, he was not really taken very seriously. It was pretty discredited for a long time, but he was onto something, as we'll see. It wasn't until the 1970s that an Austrian scientist named Marcel Kinsburn came up with the idea that it wasn't the entire organism that had flipped. Rather, it was just the head. And it wasn't until 2013 that he actually published a paper on this. Although it's worth noting that these 2 authors independently came up with a theory and published in 2012. So what does this axial twist actually look like? Here's an image from that 2012 paper asserting that the chirality, or the way something twists, of vertebrates is to the left. And here's how that would look. So you start with what we might call the regular invertebrate body plan, and only this front part twists, and suddenly what you have is the development from front to back still looks the same, hence why our unpronounceable scientist from earlier thought that these organisms were just turned upside down. But suddenly we have a lot of twisting internally. So we'll get things like this eye is connected to this part of the body and vice versa, which is exactly what we see in vertebrates, including us. Now, looking at this bumpy bit, you might think, well, how come nobody's noticed this before? And that's a very good question. Essentially, this happens early enough in development that the other tissues in the area move in order to make up for it, especially on the outside, where symmetry is valuable as a symbol of health for mating purposes. But internally, everything is staying scrambled. It's also worth noting that this type of asymmetry, called orofacial asymmetry, what you end up with here is that the neck and head have twisted, but the face hasn't fully moved in order to compensate. This axial twist explains every part of the asymmetry in our body that has always bugged me. Hands and feet not matching your brain, why all your internal organs aren't in a nice, neat line down the center, etc. But as for the question of why no one noticed it before, it's actually because it's very, very early on in development. They're called the Hamburger-Hamilton series, and this is the entire life cycle of a chick embryo from single-celled up until ready to hatch. And you might be thinking, Anton, look at all of these images. They clearly don't show any kind of twist. And you're right. And that's because the twist happens right here around stage 6 or 7, right when the nervous system has developed and it's about to start what's called somatogenesis, which is where the actual body tissues start to be formed. And as a matter of fact, if you look closely at the bottom of images 6 and 7, doesn't it look a little bit like they've been twisted and are starting to straighten out again? Obviously, we don't have the development of humans mapped out to that level of detail, but the same thing happened to us. Just like that chicken, and just like every vertebrate, we were a small group of neural cells, and we got twisted around. Anyway, there's not much point to this video. I just thought it was really cool and wanted more people to know about it. But now if you ever tell someone that they've got their head on backwards, you know you're right. Thanks for watching.